Assalamualaikum warahmatullahi wabarakatuh. I am one of University Technology Mara Mechanical Engineering student, and today I'm going to share with you my MEC 299 final year project. The topic that I have been choose is the design and fabrication of a mini projectile launcher. And today I'm going to share an overview about my project. So first, you guys must be wondering what we will discuss. Okay, on to this topic. First, I'm gonna explain to you guys who am me and the supervisor for my project. Next, I'm gonna explain to you guys what is a projectile launcher actually. And then I want you guys to have a deeper understanding of real life versus educational projectile launcher. This is where when in educational we use a mini projectile launcher. But I'm also gonna explain to you how it's gonna work. And for this project, I'm also gonna explain how the mini projectile launcher is constructed according to my own design. And in the end, I'm going to share you guys the expected result of my project and the conclusion for this presentation. Sorry for not properly introducing myself first. Okay, my name is Muhammad Razahan bin Hasran. I am one of University Technology Mara Terengganu branch students, Kampus Bukit Besi. My matriks number is 2023638794 and my group is EM11004A. The supervisor that I have been chosen for this project is Sir Abdul Rahim bin Bahari. So first, the introduction. What is a projectile launcher? Maybe you guys know what is projectile launcher already, or maybe you forget. So I'm here gonna remind back to you what it is about. Okay, first let's us dive deep into the past. In the past, application of projectile motion revolved around usage of ballista, cannon, or catapult. One of other example that I can give you is a bow, which help in war strategies or hunting. Alright, in a modern era, around World War II, we start using a bazooka, which is a hand carry projectile launcher, which help with the help of physics analysis projectile can now be studies and help humanity reach a greater height. Next is a problem statement. First, students face difficulty understanding projectile motion. Even though they can learn it from theory, they need a hand-on experiment to understand it better. Second, lack of demonstration tool prepared by the laboratory unit. Shame to say, UiTM Bukit Besi does not have the laboratory unit required to do an experiment of projectile motion. And lastly, the instrument only available out of the country, which make it expensive. The price range that we can get online for the instrument are range from 285 ringgit to 465 ringgit, which is really expensive. So for this project, I only have two objectives. First, to design and fabricate a mini projectile launcher using SolidWorks. Next is to conduct experimental investigation to determine key dynamic projectile parameters such as initial velocity, range, and trajectory. The first is to design according to buyers needed, and second is to make sure the product work just like it intended. Now let's move to scope of work. What I want on my project. First, it need to be user friendly. It need to be easy to be understand, set up, and do not take too much space for storage. Second is ergonomic. It need to be low cost product with an advantage of being portable and ease of movement. Third, education aids. It need to be accurate representation of projectile motion for students' educational materials. Lastly, interactive, adjustable angle and varied basket location for students to experiment with. From last topic, this project is aimed to help solve the rising problem and help others. So now let's move to literature review. Real life versus educational projectile launcher. Let's start out this topic with a definition. First, projectile launcher. A projectile launcher is a mechanism that launches projectiles, utilizing energy conversion to achieve motion. The force to launch a projectile to a certain distance is equivalent to the energy that being stored. In the educational context, such devices are used to demonstrate the principle of projectile motion, including parabolic trajectories, forces, and acceleration due to gravity. Next is the projectile motion. Motion of an object project into the air subject to only the acceleration of gravity. That is the topic that we need to be studied. The object that being launched is called a projectile and its path is called its trajectory. For educational analysis, the trajectory is separated into horizontal and vertical motion along its perpendicular axis. Okay, fun facts. In the context of engineering field, the word mini or the other word that give a same meaning to it usually refers to a small scale project, operation or manufacturing process that are being made with a relative smaller dimension. So anything that is flying is considered a projectile? Yes. A modern mini projectile launcher are typically designed for education purpose, with attention to portability, ease of use, and safety. Most of the design use mechanical components such as springs, compressed air, or rubber band to provide the launch force. Even with a varied design, most are commonly designed with an adjustable launch angle, a projectile holder, and a fixed base. So the base structure it provide stability and hold the launcher body in one place to prevent the launching point to change. The launcher body attached to the base structure hold the component that is used to launch the projectile, which is the spring or anything that have a potential energy to transfer. Next is angle adjuster. Hold launcher to the base and using wing screw to adjust angle. The angle adjuster should be the angle adjuster have an angle of 90 to 0 degree. And lastly, the basket hold and catch projectile in specific place. I hope you guys still understand what is the definition of projectile launcher. Because now we are going to move to how the projectile launcher works. I'm going to explain the theory behind it and how an object can move with a specific trajectory. The working principle of projectile launcher. The launcher works by converting potential energy that are stored in spring or other components with same properties into kinetic energy. To study the trajectory of projectile motion, the coordinate system is determined first. For this project, x-y coordinate is used. So the below is the formula that is used, the horizontal motion formula. We need to separate the x and y axis of the trajectory to get the direction and the force it have. Next is the spring force. The spring force is described as force exerted on an object by the end of an ideal spring. The force exerted by the ideal spring proportional to the amount by which it is stretched or compressed. Uh, I guess you already know that spring have a potential energy which can store energy when compressed or when stretched. From that, we use a Hooke's law, Fx equal to minus negative kx. On to the next topic, the most fun part, the construction of mini projectile launcher, how the product should be designed and developed. And there's an old catapult in a Y shape, is wood and rubber band. And at the back is on the right is a modern projectile launcher. That is a modern mini projectile launcher that used in international university to teach about projectile motion. From that picture, maybe you guys already have an idea how is a projectile launcher should be designed. And here I'm gonna explore through methodology on how should it be constructed. The project methodology covers two important parts. Firstly, the design for the project, and secondly, the development of the project. Since methodology is about how a work is progressed, I'm going to use a flowchart. A flowchart is a visual representation that illustrates the step and progression of a process. So first, we define the problem, and then a concept generation, evaluation concept, product architecture, configuration design, parametric design, detail design, and evaluation concept. This is where everything should be designed. And then we should have a condition checking, which if there is a problem, we're gonna repeat the evaluation concept. And if everything is fine, we're gonna continue with fabrication, a test, analysis, and report submission. Alright, just like the flowchart, first is a defined problem. It's the same as the problem statement. First, the student face difficulty understanding projectile motion. Second, lack of demonstration tools prepared by the laboratory unit. And third, instrument only available out of the country which make it expensive. Product design specification. There is three priority, the high, moderate, and low priority. So first I'm gonna talk about the high priority. The first is the product overview, which is the product name. The product name is Mini Projectile Launcher. The purpose to be compact, accurate, and education aids. The target market is students and educational institutions. Next is performance requirement, which should launch a projectile from adjustable launching angle from one point to another. Next is component availability. All components of manufactured process are not restrictive because it is available and accessible in any hardware shop or online market. Next is ergonomics. It should be simple to operate and effective on giving wanted result. Usability. Easy to set up and straightforward instruction. Features and functionality. Adjustable angle from 0 degree to 90 degree. Next is the moderate priority. The cost. The cost should range from 25 ringgit to 100 ringgit for a construction. Next is a dimension and weight. The overall dimension is 1,500 millimeter in length and 80 millimeter in height. The total weight should be not exceeding 10 kilogram. Aesthetic and design. The design is aimed to be simple, easy to be understood and operated. The base can be folded to make it more compact and portable. Materials. The materials can be used for a long time, strong to reduce tear after use, cheap and lightweight. Next is the low priority. First, the quantity. The experimental kit can launch one projectile at a time. Next is the process. The fabrication process will use simple and basic process such as sewing and drilling. After that, we move to the concept generation. The first is the morphological chart. A morphological chart serves as a structured approach in engineering and design. Its purpose is to explore and create different combination of design features or components. It helps recognize, organize, and investigate the full spectrum of possible relationship within a multi-dimensional problem. After assessing every material that I want from the morphological chart, I move to the push chart. Push chart method serves as a valuable approach to evaluate and select the most favorable design concept from a set of alternatives. It involves comparing each concept to a reference concept and assessing whether it's performed better, worse, or similarly across various criteria. And from this, the design that I have been choose is concept one because the total score is higher than any other concept. After identify and understanding the function, we move on to the product architecture, which can explain about the component. Product architecture refers to how the different functional parts of a product are organized and interact with each other's component. This helps determine the product development process on activities architecture will focus on. First, the base structure is for structure support and stability. The launcher's body hold the spring and launcher component. Angle adjuster hold launcher to the base and using wing screw to adjust angle. Spring mechanism launch the projectile but transfer stored energy to it. Hinge connect base and make it fold. Screw secure the hinge in place. Wing screw connect and tightening the angle adjuster to the launcher body with the help of hex nut at the end. Basket hold and catch projectile in place. Next is a detail design. After make a decision on the product specification, we're gonna make a detail design, giving a more detail on the design chosen to help in fabrication of the mini projectile launcher. This subchapter help giving an overview of a final design and result expected following the product specification. So here is a base structure which have a hole which gonna hold the launcher, and the other one is the base structure with a hole. So these two base gonna connect and with the help of hinge allow them to fold and make it compact. The other component that need to be fabricate is the launcher body and angle adjuster. And from all of those components, this is the assembly drawing of all the component. After the design specification, which we determine what material we use and what other component that we need. This is the list of material that we want. First is screw, second is hex nut, third is hinge, fourth is plywood, fifth is epoxy adhesive, sixth is ping pong ball, seventh is spring, and lastly is the wing screw. The plywood is used to make the launcher body, angle adjuster, and base structure. Ping pong ball is our projectile, and epoxy adhesive help in gluing the plywood. Last but not least is the expected result. The mini projectile launcher is expected to work just as the design intended, which are efficient and long-lasting. It expects to launch the projectile from adjustable launch angle across the base structure while remain compact for strong and portability and maintaining overall sturdiness. The trajectory is also expected to have high rate of accuracy projectile motion following predicted parabolic path. The projectile would land at the same point, reach a same result after multiple launching time when the angle and the force is not changing. Last, the experimental kit is aimed to improve student understanding of physics concept. It is expected to remain easy to be operate and experiment using the kit and reduce setup time for the experiment apparatus to give students more time to discuss. Okay, this video is come to the end. I hope you guys understanding the thing that I'm trying to present to you guys, and even if you don't, just ask on the comment below, and thank you for watching.